Right, because and so let's just make a estimation. Why do we think? Okay, so Jack just had a really great point. He said when the magma cools, one of them has where you can really see the crystals, and one of them you can't. Right, you can't really see the crystals. Now, could you decide that from what we just read? Like, if we were thinking about that's kind of almost like kind of taking this and applying what we've just read, right? So let's read that again. The igneous rock. Says on there, if the intrusive igneous rock has cooled deep in the Earth's crust for thousands of years, it will have large crystal formations within them. Interesting. And then the extrusive igneous rock, when magma reaches the Earth's surface and cools quickly, it doesn't leave it enough time to create the very small crystals within them. So it's very smooth. Like I have, you guys want to see it?
That's what I was thinking of, because it doesn't have time to make crystals if it's really slow, if it's really speeding up and cooling quick.
I think that extrusive igneous rocks are so cool. Do you guys?
That you have one?
Is it? Well, I actually borrowed these rocks from Mr. I'm that big. Do you? I borrowed these from Mr. Love. You guys are going to get to learn all about this right after Christmas.
I own those. Like, isn't that from other?
Yep. So then that would be an example of an extrusive igneous rock, and this would be an intrusive igneous rock, right? Because it's actually inside the Earth, and the crystals have plenty of time to just, be together and not get, and they cool nice and slow. Okay. So that's good. If you guys can stay focused, I'll pass these around. Okay. And you can pass them around to your friends. Okay. All right. Well, that's awesome. Anybody else? What else? Oh, Caitlin, what do you got? You would like to read. That's awesome. They're going to pass around. They'll make it to everybody. It's okay. All right. Sure, Gavin. Caitlin's going to read sedimentary, and Gavin wants to read metamorphic. Now, you guys listen up, okay? Because a part of what's going to happen today is you're going to need to write a paragraph later. I really suggest that you follow along as you're reading. Like Elda is doing a wonderful job. So look at, she's got her pencil ready to go. Circle and highlight some words that you think you might use later on when you get ready to write. Okay? It'll make it a lot easier to write your paragraph. Okay, awesome. Thanks, Caitlin. Nice and loud, please, okay?
Sedimentary rocks. Over millions of years, rocks are worn down by water and light. Sedimentary rocks are formed by sediment that is deposited over time, usually as layers at the bottom of lakes, rivers, and oceans. The sediment can include rock particles, minerals, small pieces of plants, and other organic matter. Sediment is compressed over a long period of time before constellation into solid layers of rock. Sedimentary rocks from layers called strata, which can often be seen in exposed cliffs.
Okay, thanks, Caitlin. That was awesome. I'm just going to finish writing this. So we did, I guess I put this in the wrong order, but whatever. Caitlin, that was great. So what can someone tell me, what did you guys hear there? What went, Jack?
I was hearing that it has to wait a long time until it can consolidate into a solid.
Consolidate. That's what that word was. Consolidate. Okay. And there's a key component here that sedimentary rock needs. Can you guys kind of try to it's called infer what it means. What does it need? Go ahead. Keep
Erosion.
Erosion starts it. You're right, because all those particles come from the erosion. Great. That's exactly right.
Food.
I kind of think erosion would be a great vocabulary word.
A river.
A river. Caden, I love it. And what is a river?
Large body of water.
Water.
Running.
Sure, I think water, but I think the key to a sedimentary rock is that it needs to have some water to have the actual reaction happen. So you're right, it needs to have the compaction, the erosion, because it needs the particles first. And then it needs the water to for them all to kind of like stick together.
It would be cool if it was a sedimentary rock that had like a bubble of water in it when it formed.
Well, that would be. How would they under it? Would have to almost be like something to be a bubble, right? Well, that's perfect. You guys are on top of it. You're getting it. So, Gavin wanted to read anything else about the sedimentary rock? Anybody see anything else in there? So it can have anything in it, right? It needed water, didn't it? Okay, Gavin would like to read metamorphic for us.
Metamorphic rock from deep within the earth when the heat and pressure are applied and to extinct rocks.
Existing
rocks.
Yep.
The extreme heat and generated by magma deep in the Earth's core particularly melt the rocks.
Can you guys, what is that word? You guys,
Partially.
partially. Great job, Connor. Thank you.
I'm not that good at pronunciation on a whole lot of words.
Yeah, you did a great job there. Go ahead, Gavin. Thank you.
Melt the rock combined with the pressure of so deep in the earth, the rocks chemically change.
Nice.
The rock was subject into a metamorphic rock. The final state of metamorphic rock depends on the amount of pressure the rock was subjected to. The amount of heat the rock was subject to and the amount of time the rock was formed. When the heat and pressure are applied to limestone for many thousands of years,
Uplift. Uplift and erosion. That's a tough word. I think it's time we write it on the board, right? I think erosion has really been kind of one of those words we've used a lot so far today. So you guys, if I was you guys, I would bet you have that underlined or highlighted in your work right now, don't you? Because I think we have said that a lot of times. Okay, erosion. All right, so, well, let's talk about it. What is that metamorphic rock doing? What's going on with the metamorphic rock? Take a second to think about it now. Let's see if can we hear from someone we haven't talked to yet today?
What?
Someone else thinking about it. Think about tell me something that you just heard or learned about metamorphic rocks that we just read about. Somebody we haven't talked. Chase, what do you got?
The magma melts the rock and puts pressure to make new rocks.
That is such a perfect summary. That's exactly. What else do you got, Katie?
I learned that one very common metamorphic rock is marble.
It's marble, right?
I
Jack, you always got lots of good
didn't know
stuff,
that for thousands of years, uplift and erosion help metamorphic rocks to bring up to the Earth's surface.
At the surface, yeah. So that's how a lot of times we see them like up in, we see them pushed up, right? Because of the uplift and erosion of the uplift of the earth.
And I think I heard about a museum that they're digging like tons of kilometers down, and they're finding tons of fossils and stuff, and they've reached magma.
Oh, they got to the magma. Wow, that's
and then
really
they're
deep.
building the whole museum over, and I'm just like, that's so not safe.
So not safe. Very good observation. I love that. It's not very safe.
That's 9 miles down.
No.
Is where the magma is?
Yeah. Magma starts 9 miles down.
In some places on the earth, doesn't it?
Actually, most places.
Sometimes it's like
I've learned that in
Sometimes, because the core probably is pretty hot too.
actually 15 kilometers down when you reach magma.
Well, you guys, I'm pretty impressed with how much you guys already know about rocks. We're not actually having to be a part of your, what else you got to say, Jack?
That there are 2 states of to become a metamorphic rock, and that's the heat from when it's in the volcano or the ground.
Yep.
That puts it through the first stage of chemical change, and then the pressure puts it through the other stage.
Wow, that was a good summary, huh? Good job, Jack. All right, so with that being said, was there any more of these papers, Rachel, or was this the last one? Did we have any other ones? I mean, just enough, huh? You okay? All right, so good job, you guys. So we are going to go ahead and, should we just listen to the video again because we have time? Because it's super fun. And then we're going to fill out this piece of paper, and then we're going to make a rock, and then you guys get to write a paragraph. That's our plan. Out of gum. What? Yes.
Awesome.
Well, okay, let me ask you this. Would you guys, all right, let's just answer these questions. Should we write them down? Yeah, we better do the right thing. I'm taking a test right now.
We better do the right
We better do the right thing, you guys. Well, because you need to learn something while I'm here today. So I can be a real teacher.
Yeah, good job. Wait, no.
All right.
I hope you do the right thing.
I know, right? So the right thing is we have to fill out this piece of paper right now so that you guys,
I'll just
you know, okay. Well, Rachel, do you want to come up here and write? Come on, friend, come.
first answer.
It'd be really hard to write to see what she's writing.
It's okay. I'm going to help her. It's good for her.
Yeah.
All right. Let's come over and stand over here. All right. Let's. Can someone read number 1 to us, please? Megan, thank you.
What kind of rocks may have varied varieties of color and could be found where there was once a river?
Okay, so this is varied layers, right? So what kind of rock may have varied layers? What does anyone know what varied means? Jack?
Like
Different.
Different. Yep. Anyone else? Any suggestions?
rocks is different.
Okay. So we have varied layers of color and can be found where there was once a river. Because what had Gavin told us? That we needed to have water. Oh, I'm sorry, Katie. You haven't read it.
Where the volcano was, it's going down this way because
The way they cooled. All right, so let's use our reasoning skills here. Now, what is this telling us? So it has varied layers of color, and it can be found where there was once a river. Where did we read about a river in our reading? Someone we haven't talked to. Sophie, thanks.
sedimentary rocks.
Sedimentary rocks, right? We decided that we needed water to make that work. All right, so if you can you write sedimentary right there? S-E. So everyone write it in there, please. Write answer number 1 is sedimentary. S-E-D.
S-E-D.
I-M. M-E. Or did I say I-M? Yep. E-N.
E-N.
T-A-R-Y.
T-A-E-R.
R-Y. T-A-R-Y. R. Okay, sedimentary. Great. Can someone read us number 2? Who has it? Riley, great job. Go ahead, Riley, read us number 2.
What kind of rock would most likely be formed deep underground for thousands of years?
Oh, Gavin, what do you got?
Igneous rocks. Yes.
Well, that's true. You know what? I think this question kind of actually could be answered by 2 of them, couldn't it? Because
Metamorphic also forms underground.
underground. But I mean, Gavin is so right though, because we had said,
It just says it right there.
yeah. I mean, it's designed to be able to answer number.
So do we write it?
Yeah, well, that's right. I think we should write both. I think that's both, huh? Let's write metamorphic, M-E-T.
I think it wants metamorphic though.
I do too, but let's M-E-T-A-M. A-M. So it's M-E-T-A-M-O-R.
Wait, M-E-T-A-R-A-M.
O-R. P-H-I-C. H-I-C, yep.
I-C.
And I think that it's really valid to think that we could actually call it igneous too, because it's that magma cooling for a long time, right?
Yeah.
So let's go ahead and write and igneous.
I did like a
Oh, perfect.
I did
Metamorphic
And, okay, so now we're going to write igneous.
dash slash or dash or and.
Okay, come on now. Here we go. I-G. Everyone write igneous. I-G-N-E-O.
N-E-O.
U-S. And what were you going to just say right now, Avery? Can you point that out? It's on the paper, right? So what have I talked about before? Using your resources. So right now we're trying to write these words and they're on your paper, right? Okay, who wants to read number 3? Brendan, do you want to read number 3? Okay.
Name 2 elements that create a metamorphic rock.
Now we've talked about this, Gavin, haven't we? What 2 elements create a metamorphic rock? Ooh, Chase, what do you got?
Pressure and magma.
Pressure, for sure. And magma, because what is the magma, though?
Pressure. Like hot. Yeah, it melts. Pressure, heat. Pressure and heat.
And so, and what is that? What is the magma? What's called?
Heat.
What is its temperature?
Heat. Tons. Hot. Thousands of degrees.
Super hot, right? Thousands of degrees. That is like super, super hot.
It can melt titanium. That's pretty hot.
So we are going to name the 2 elements that create metamorphic rocks. Now I liked Avery pointing out how she was able to find a resource to figure out how to spell what words we're going to write there. So Chase has just told us that we need magma because of the heat, and we need pressure.
Or just pressure and heat.
Pressure and heat, however you want to write that. And you should be able to find that.
I just put a heart on there.
Because she's funny like that. Okay, pressure. Go ahead. So P-R-E S-S-U-R-E. And then and heat. Heat. H-E-A-T.
You press the off button.
Wait,
H-E-A-T. I think I must have gotten unplugged because I definitely didn't press the button. I would guess she probably, that's our problem right there. It was, we just bumped the cord. No worries. Okay, who wants to read number 4 for us? Chuck, thanks, buddy.
Here you go.
What are the 2 types of igneous rock?
What are the 2 types of igneous rocks? Someone we haven't heard from today. Can they tell me? Ava, do you remember? No? Everyone think for a minute. Take a look at your igneous rocks up top there.
Extracts of igneous
No. Can we look, Mariah, can you look at your top and see what 2 types of igneous rocks are there? Nate, what do you got? No, crystals. Why don't everyone take a look at your igneous rocks here?
Oh my God. What are you doing up here anyways? I'm looking.
Okay, but now where can you guys figure it out? You can look up at your igneous rock paragraph. Caitlin, what do you... Crystal. Yeah, well the size of the crystals kind of let you decide what type of igneous rock it is. But let's look at the question again. What are the 2 types of igneous rock?
Did you do that heart? I pushed those hearts.
Say it again, please.
Stars. Hey, it's coming, it's coming.
Okay, sit down. Thank you. Intrusive and extrusive. Intrusive and extrusive. Okay? So that is the 2 types. Now where can you find that? So when I was asking you to look back and use your resources, right, Elda? Can you look in their top paragraph, and there's an intrusive igneous rock.
Should I circle that?
You can circle it, and then you need to write it in for your answer. You guys need to be able to think where your resources are within your material that you're reading to help you figure out your answers and how to spell things, your vocabulary, right?
Rachel, can you scoot it up so you can see the bottom half? Yeah.
She's just circling. So she's circled intrusive, right? And then we also know that we need to have the word extrusive. So those are our 2 words we're looking to have in that answer. Okay? All right, great. Okay, so for question number 5, now I want you all to think for a minute. No one yell out this answer after we're done reading this question, okay? I'm going to read it to you. How are igneous rocks different from sedimentary and metamorphic rocks? What makes them different? Now think for a minute. I want you all to think and then write a sentence down, because it's a simple sentence, you'll just need to think. How are igneous rocks different from sedimentary and metamorphic rocks? Once you have a seat, thank you so much for all your help. And if you could please write one sentence. Write one simple sentence on there with your own thoughts, okay? So this is your thought on what makes them different. Okay, so you guys all need to have a sentence on number 5 before we move on to a super fun project.
Okay, well, my sentence.
Let's focus on the small stuff.
Wait, what is it?
So think about what is the difference.
Dry lava. That was that dry lava. That's your.
Okay, so you should all, if you don't have a sentence and you're goofing around, guess what's going to happen, girl? You are not going to, do you want to do our next project? Okay, let's focus. Brendan, focus. You need to have, yeah, we'll watch a video again for sure too, but you guys need to have a simple sentence written in your own words. And we're going to think about it out together, but I do need you to try to make your own thought. I'll get it for you. You need to try to make your own thought and answer that question, okay? And we're all going to get an opportunity to read them. You guys are all going to read out your sentence to the class. So I want you to be prepared to read your sentence to the class of your own thought, okay? I guess we're going to shut this off right now. Okay, is everybody thinking about it? I'm going to use it again in a minute, so no big deal. Okay, so let me have everyone keep thinking. Read it. Think about your sentence you have written, okay? And we're just going to go around the room. So just make sure you have it written perfectly well. And we'll just there's no need to raise your hand. We're going to go around the room. Okay, so everyone should have a sentence by now. So you're going to be listening for a little while. So I want everybody to read. We're going to start off and we're just going to go around the room. We're going to start over on this side and we're going to work our way around. If you're still not certain on your sentence, keep thinking into these other ideas and proceed to make sure you get your own idea on there. Okay? Elda is going to start us out with what she has to say. Okay, Elda, so let's read the question again. The question says, how are igneous rocks different from sedimentary and metamorphic rocks?
All rocks become as igneous rocks.
Exactly. Look what she was. Great job, Elda. What did she do? She looked back at her resource in her paper and seen that it said, the very first sentence says, all rocks begin as igneous rocks.
That's what like all of us did.
Right? Because that's really the only way to get a rock is it has to start with magma. Let's go around. Gavin, what'd you write?
All rocks start out as igneous rocks.
Perfect. Jack, what do you think?
Yeah, this is because they are formed by magma. Even though all rocks start as igneous, others go through changes and are no longer igneous rocks.
Whoa. Perfect. Nate, you want to go?
Yeah, so here's what I wrote, but I'm going to do like the all rocks start out as igneous rocks. But here's what I said.
No, what you have is perfect.
Underground.
They're what?
They are formed underground. Igneous rocks are formed underground.
Well, now let's talk about that. Now we just got done saying that igneous rocks, what can the magma do that makes it cool differently? So look at your igneous rock. Don't re-erase your sentences. You guys' sentences, I'm sure, are great. There's no right or wrong answer. It's what you think.